Ladies and gentlemen, Mr. Cassandra is back with another instructional video on chapter 6.3. In this case, we're skipping over chapter 6.2. We're sticking with similarity and similar triangles in this chapter, and we are talking about the angle-angle similarity postulate, which states if two angles of one triangle are congruent to two angles of another triangle, then the two triangles have to be similar. So therefore, if you look at my example here, I have a triangle right here, triangle RTG, and I have another triangle over here, and angle G is congruent to angle B, angle R is congruent to angle F, so therefore two angles of this triangle are congruent to two angles of that triangle, therefore these triangles have to be similar. In fact, we know that if two angles of one triangle are congruent to two angles of another triangle, by the third angles theorem, the third angle also has to be congruent. So actually we can match up all of the corresponding angles. And then that's going to make our similarity statement super simple. So what is the similarity statement for this set of triangles? Well, I'm going to name the first triangle however I want. I'm going to call it triangle RTG. And I'm going to say that that is similar to, and I'm going to put my similarity symbol there. And now I cannot just put the other angles in any order I want. They have to match up. So how do they match up? Well, let's see. R has 2 marks, so F has 2 marks, so R and F have to be corresponding angles. So if R is in the first spot, F is in the first spot. T is in the second spot, that's got 3 marks. K has to be in the second spot. That has 3 marks. And then obviously that leaves me with B, so let's just double check. G and B both have 1 mark, and there we go. Okay, so we've got RTG is similar to FKB. That means that angle R is congruent to angle F, angle T is congruent to angle K, and angle G is congruent to angle B. Now don't forget, once you now state these triangles are similar, you can go ahead and you can write a proportionality statement. This will help us to solve for missing sides, like I'll do in the examples. RT is in a ratio with FK. This is from last chapter. TG is in a ratio with KB. And RG is in a ratio with FB. And all of these ratios have to be equal. And their perimeters would have to be equal also to the scale factor. So these all reduce to the scale factor. All right, so let's do some examples. Let's hit it. Here we go. Hit it. All right, so I'm going to zoom in over here a little bit. Let me just adjust my camera so that way it's a little bit, instead of being so far away. Let me zoom. That's a little better. I think that should be good enough for right now. I think it's fitting the whole problem. All right, so here we go. It says, use the diagram to complete the statement. By the way, these are the example problems that are in your online textbook, so you can look at these and follow along. If you can't see my handwriting or see these numbers, you can look in your book. Okay, so use the diagram to complete the statement. So the first statement is triangle ABC is similar to what? Well, let's see. According to my angle-angle similarity postulate, because angle A is similar to angle F, congruent to angle F, and angle B is congruent to angle E, and by the third angles theorem, then C would have to be congruent to D, I can now write my similarity statement. What does my similarity statement look like? Well, A should match up with F, B should match up with E, and C should match up with D. Please keep in mind it's not just because they're in the same spots in the pictures here, because these triangles can be turned in different ways, and we're going to see some examples like that as well. Now, how do I use this similarity statement to help me solve the next problem? Well, BA corresponds with FE, so that goes over here. FE. AC corresponds with FD, so I'm going to put FD there. And CB, the last 2 letters, correspond with ED. So I'm going to put ED there. And now I have my proportionality statement. All right, now let's take a look at number 5. 25 over what is equal to blank over 12? Well, 25 is AC, so that's AC. And AC corresponds with FD, right? So FD would go here, and FD is 15, so actually I could put 15 here. I'll just put FD over here so you can see what that means. And then 12, let's see, 12 in this triangle is EF. So that's EF. So what corresponds with EF? Well, BA, right? BA is Y. Okay, so that's what's missing from those fractions. And I do the same thing with number 6. Blank over 25. So something corresponds with 25. 25 is segment AC. AC is the first and the third letters, so FD goes up here in the numerator because that corresponds with AC. That's the ratio I'm looking for. FD is 15, so I put 15 up here. Okay, and then it says 18 over blank. Well, 18 is ED, and ED corresponds with BC. And BC is X. So what I did here for numbers 5 and 6 is I ended up setting up proportions based on the ratios. Now they want me to cross multiply and solve. So how do I cross multiply and solve? 25 over 15 equals Y over 12. So let me move this up so I have a little room to work over here. So I'm going to do some scrap work here. 25 over 15 is equal to, let me make sure my camera's good. 25 over 15 is equal to Y over 12. So you're going to cross multiply. 12 times 25 is 4 times 3 times 25, which is 300. Okay, and 15 times Y, and divide both sides by 15 because that is the rule for cross multiply and then divide by the coefficient. You get Y is equal to 20. So Y is 20. I'll go back to that in a second. Now, number 8 asks us to solve the other one. So without moving my camera back up, I'll write down the other problem. 15 over 25 is equal to 18 over X. So once again, that's number 6. That ratio will help me solve for X. So I'm going to cross multiply there. Boom, boom. I get 15x is equal to, let's see, 16 times 25 is 400, 450 I think this is. Divide by 15, and I get x is equal to 30 when you divide that. So that is y. Now I'm going to pop those back in there again. Let me see if those make sense. So remove my 20 and 30. So let's see if that makes sense here. Now that I've solved for x and y, if I put these in order, 12, 15, and 18, and then I put all of these in order, 20, 25, and 30, shouldn't they all reduce to the scale factor? And they all reduce to, let's see, 15 over 25 reduces to, divide by 5, 3 over 5. And these are both divisible by 4, so if I divide 12 by 4, I get 3. And if I divide 20 by 4, I get 5, 3/5. And if I divide these by 6, I get 3 over 5. So the scale factor is 3/5. All right, so let's do a couple more examples and wrap it up. It says, in exercises 9 through 14, determine whether the triangles are similar. And then here's the key that some people have been missing. Make sure you do both parts of the problem. Not only do we have to determine if they're similar, but we have to write the similarity statement. So first of all, if I'm using angle-angle similarity, I need to know what all three angles are if I can. Now for number 9, they tell me this is 48. I know that's tough to see, so I'll write that in there a little bigger. That's 48. That one there is 42. That is 90. So they both have a 90-degree angle. That's great. But I can't make any judgment on this until I find out that third angle. Well, how do I find the third angle of this triangle? Well, if it's a right triangle, and that's 48, these two are supposed to be complementary, that's got to be 42. How did I get that? I subtracted 48 from 90. you also could have added 90 and 48 and subtracted it from 180. Aha! Well, that's 42 and that's 42. So I got a pair of congruent angles here. I got a pair of congruent right angles here. And that means this third angle here has to be 48. And now I'm going to write my similarity statement because, yes, these are similar by angle-angle similarity. And now I'm going to write my similarity statement. First three letters of this one doesn't matter. I'll call it GFH. Is similar to, now G is 48 degrees. That matches up with L. And then F is 42 degrees. That matches up with K. LK. And then H matches up with J. So GFH matches up with LKJ. And you are done. All right, number 10. I don't know how many minutes this video is so far, but I'm going to try and cut it short in a bit. But I do want to do one or two more examples here. So let's take a look at number 10. They tell me this is 45 degrees. I don't know if you can see that there because it's a little bit far away. So I'll write them in a little bigger. So this one over here is 45 degrees. Well, in other words, these two angles here are congruent to each other, right? Well, do I have angle-angle similarity? Angle-angle similarity means I need two pairs of congruent angles. Well, I just got one pair. But if you did your project and you remember your vocabulary, you remember that vertical angles look like that and they're congruent. So therefore, these two triangles are similar. And let's go ahead and match up their congruent angles. I'll say triangle MNY. MNY is similar to triangle M matches up with X because those don't have any marks, so that by a third angles theorem they have to match up. N matches up with Z, and then Y matches up with itself. And bingo, you are done. All right. What about, let's move down, let's skip down to number 16 now, because I want to talk about how to get, how to find, well, no, I don't want to do that, because I want to talk about these markings here, because some people have been confusing these. This kind of makes me worry because we talk about parallel lines. These red arrows here are parallel lines, and parallel lines give me congruent angles. This chapter is angle-angle similarity, so therefore you should be thinking to yourself, if I've got parallel lines, I have congruent angles. Now, what you might not remember is if they only give me part of the picture, I should probably fill in the other lines so I can make my corresponding angles right there. And we know that corresponding angles are congruent. And I also have corresponding angles if I continue this over here. I also have corresponding angles here and here. So actually these two triangles are similar. Now how do I know that there's even two triangles there? Well, you got this small triangle here. I'll call it triangle MNP. And then you've got this bigger triangle here, which looks like that's the letter L. I put a little dotted line there, that's the letter L. And then N, and then that looks like a Q or an O. Then I'll put a Q. All right, so I just have to match up the corresponding angles. MNP corresponds with LNQ. So please watch out for that, okay? That is always true. Whenever you have this picture, and I'll draw it on the back of something. Whenever you have this picture, when you have a triangle, and then they draw a line here, and these are similar, or these are parallel to each other, you always have corresponding angles. Just like whenever you have a bow tie like so, you always have congruent angles for vertical angles. Okay, so watch out for those types of pictures. All right, so I think I can just do one more example and then I'll cut this short. Anybody else who has questions can schedule a Google Meet with me if you still have questions on this. But here we have number 16. It says, what is the value of P? P is this one right here. And we need to set up some sort of a ratio, but I can't just match up any old sides. I have to make sure I match up the angles of these triangles. Now, first of all, I've got parallel lines here and here. And whenever you have parallel lines, you have congruent angles. And whenever you have the bow tie in parallel lines, we learned from congruent triangles that we've got alternate interior angles here. These are congruent to each other here. And then we've got vertical angles here. So you would have to spin this triangle around. you would have to spin this triangle around to get it to match up with its corresponding angles, which means 12 corresponds with 24 and 10 corresponds with P. And then you would cross multiply and solve that. And I'm going to cut right to the end of that. If you cross multiply and did 12, well, let me go ahead and do it. I know that there are still some people who are struggling with solving equations. 12 times P is equal to 240. Divide by 12, you get P is 20. Okay? And that is it. Those are some example problems. Please look at your study guide, your example problems in your textbook. I hope this video helped with angle-angle similarity, and you will have a problem for homework, a problem set for homework. Please make sure you read the directions. Have a good day.